Hello everyone, Mrs. Venti here. Today we're doing a trigonometry video for grade 10s. We are using the Mind Action Series textbook. We're going to do exercise 4, which is found on page 169, 170. Specifically in this video, we are going to look at how to solve a trigonometric question when you have more than one triangle. So you already know that when we are dealing with trigonometry, we use the acronym SOHCAHTOA. So when you are dealing with trigonometry, you need to always, at the beginning of your exercise, write out SOHCAHTOA so that you have got that as a reference point. Let's look at question 1. In this question, we have triangle ABC and we have triangle BCD, or we have the quadrilateral ABDC. Now, they are asking us, what is angle B1? We know this because I marked it in red. How do we figure out angle B1? Remember, whenever you are dealing with trigonometry, you need 3 pieces of information. You need one angle and 2 sides. So in this instance, they are asking for the side, the angle. So there we've got our angle. Let's name it theta. And we've got one side. So what we need is one more side. How do we figure this out? In order to answer this question, we can use the side BC. Why did I choose BC? Let's look at triangle ABC. In ABC, I've got an angle and I've got a side. And then again, BC is the common side that is the same in triangle ABC and in triangle BCD. So if I figure out BC, then I will be able to answer the second part to the question. So if I have one angle and one side, I can calculate my other side. Let's have a look at triangle. We're going to use triangle ABC, and we are going to answer the question based on that. If I have, this is my angle 42 degrees. Next to it, I have adjacent, and then BC ends up being opposite. Adjacent and opposite. I know adjacent and opposite gives me tan. So I can say that tan of my angle is 42 degrees. Tan of 42 degrees is going to give me, tan is opposite over adjacent, and opposite is unknown, so that's BC over adjacent is 20 centimeters. So in order for me to isolate BC, I am going to say on both sides multiply by 20. So now I've got 20 tan 42 degrees is equal to BC. That is what I want, right? I want the length of BC. My next step is to use the calculator. So I'm going to input exactly what I have. 20 tan 42, and that gives me an answer of 18,008. So I now know that BC is equal to 18,008 centimeters. But this doesn't answer my question, right? Because my question says, what is angle B1? So now I'm going to work out angle B1, and I am going to say, I now have B1. Next to B1 is BC. So this is adjacent, right? And the long one, BD, is hypotenuse. So using my yellow, I am going to say adjacent and hypotenuse is that. I've got cos. Cos of angle B1 is going to be equal to adjacent, which is, we've just calculated it, 18,008 over hypotenuse, which is 24. Now I just work that out. So because I want to have the angle alone, I am going to use my inverse function. So angle B1 is equal to, let's put the 1 at the bottom. Angle B1 is equal to cos minus 1 of 18,008 over 24. My next step is to use my calculator. So I am going to say second function cos 18,008 over 24. Then I close my bracket, and that gives me an answer of 41,380. So to 2 decimal places, I'm going to use 41,38. Angle B1 is equal to 41,38 degrees. And that is my final answer. So to repeat the steps, first things first, I write out SOHCAHTOA so that I have something to reference. Then I figure out, what am I asking? What is the question asking for? Question is asking for B1. What is the common side in this question? My common side is BC. So first I solve for BC, then I use BC to calculate angle B1. Question 2. SOHCAHTOA is my first step. Now I look at my question. My question says solve for angle H. I know this because it's in red in the drawing. Okay, so my common side is going to be GE. Okie dokie. So let's start. We're going to solve for angle GE. In triangle FEG, we are going to look at, here I've got hypotenuse. This is my angle, so this one is opposite. I have opposite and hypotenuse. Opposite and hypotenuse is those two, so I have sine. Sine of 51 degrees is equal to opposite, which is EG, over hypotenuse, which is 12. Okay, now I want to get EG alone, so I'm going to say multiply by 12 over 1, multiply by 12 over 1. These two cancel out, and what I'm left with is 12 sine of 51 degrees is equal to EG. Input into the calculator, 12 sine 51 equals 9,32575. 9,32575. EG is equal to 9,32575. Okay, now I've got my common side. Next up, I want to calculate for angle H. So now I'm going to say in triangle GEH. That's going to be my orange. So if this is my angle, then this remains opposite. And this over here is my adjacent. I have opposite and adjacent. Opposite and adjacent is tan. So I say tan of angle H is equal to opposite. We've calculated opposite. That is 9,32575 over adjacent, which is 4. So angle H is going to be inverse function tan minus 1 of 9,32575 over 4. And I close it. Now I go to my calculator. I want to point something out to you. Notice that I have got the answer from the previous question, 9,325751573 or 37. I'm going to use answer instead of typing that out. So I'm saying that I'm going to go tan minus 1. So to do that, I say shift tan minus 1. Then I'm going to say answer. Instead of typing 9,325, I am just saying answer over 4. So I use the previous answer that I have from the previous question, and I press equals. So angle H is equal to 66,78 degrees. That 4 tells me 8 stays the same, so it's 66,78 degrees, correct to 2 decimal places. Angle H equals 66,78 degrees. That is your final answer. Question 3, they are asking me for the length of PR, and I know that my common side is QR. Start off by writing out SOHCAHTOA, so I have something to refer to, and then I'm going to start by calculating QR. I'm going to use this triangle, so I'm going to say in triangle SRQ, I have got QR is opposite and 11 meters is the hypotenuse. O and H, that's OH, that's sine. So I'm going to say sine of 63 degrees is equal to opposite, which is unknown, so QR over hypotenuse, which is 11. Then I multiply both sides by 11 in order to get QR alone. Denominator cancels out with the numerator. So I have 11 sine of 63 degrees is equal to QR. Now I'm going to input this exactly this way into the calculator. You type 11 sine 63 and you get an answer that says that QR is equal to 9,801 dot dot dot. Okay, so now we have the common side. Our next step is going to be in triangle PQR, and in this triangle we want to work out PR. So this is our angle, and we know that QR is opposite, and we know that PR is hypotenuse. Opposite in hypotenuse is sine. So I'm going to say sine of 48 degrees is equal to opposite 9,801 over hypotenuse, which is PR. I want to get PR by itself. So I'm going to multiply both sides by PR in order to get PR alone. So that cancels out. And what I have now is PR sine of 48 degrees is equal to 9,801 dot dot dot. I still want PR alone, so now I want to get rid of this sine 48. So I divide both sides by sine of 48 degrees. And what this allows me to do is to cancel this with this. So on the left hand side, I have PR is equal to, on the right hand side, I have 9,801 over sine of 48 degrees. So you input that exactly the way it is into your calculator, and you should have an answer of PR equals 8,82 units. Our units are meters. 8,82 units, correct to 2 decimal places. Question 4, asking for the length of AB. Our common side or common length here is going to be BC. So first I start with SOHCAHTOA, and then I say in triangle BCD, which is the one I start out with, I am going to say this is my angle. 7 centimeters is adjacent, and BC is hypotenuse. So adjacent and hypotenuse is cos. I have cos of 63 degrees is equal to adjacent 7 over hypotenuse BC. Let's solve for BC. Now, what I want to point out to you, a quick way. So what we're going to do, our steps are, we're going to multiply by BC and divide by cos 63 in order to get BC alone. But just a quick way of doing this is I can swap this and this, can swap places, and I get the same answer. So let me do it at the bottom. I'm going to swap it out. I'm going to say, okay, BC moves to the left hand side is equal to 7 over cos 63 degrees goes to the denominator because I swapped the two out. Let's see if this statement actually holds true. In order for me to do this using the actual mathematical steps, I'm going to multiply by BC on both sides, and I've got BC cos 63 degrees equals 7 because these two cancel out. My next step is going to be divide by cos of 63 degrees on both sides. 63 degrees, so this and this cancels out, and this leads to that. So in order to skip the middle two steps, I just swap them out. But I'm showing you the middle two steps so that you can understand exactly why I do the swapping, because the end result is swapping it out. So BC is equal to 7 over cos of 63. And if you input that into your calculator, you are going to get a result of 15,4188 dot dot dot. Now that I have my common side, I want to calculate AB. So I'm going to work in triangle ABC. And in this triangle, I've got my angle is 25 degrees, right? AB is opposite of 25 degrees and BC is adjacent of 25 degrees. Opposite and adjacent gives me tan. So I'm going to say tan of 25 degrees is going to be equal to opposite AB, that is unknown, over adjacent, which is BC, 15,4188 dot dot dot. Okay, now I am going to multiply both sides by 15,418, 15,4188, and I get 15,418 tan of 25 degrees is equal to AB. So if you input that into your calculator, you're going to say AB is equal to 7,1899 dot 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 dot, and we're going to 2 decimal places, so AB is actually 7,19. They don't tell us, or centimeters. They do tell us it's centimeters in this triangle. All right, one last one. This one is a little bit more complicated because we have to use more than trigonometry. So we have triangle KLM, and we know that KM is equal to LM, which is equal to 20 meters. Now automatically, if two sides are equal in length, then we know that we have an isosceles triangle. And since they are isosceles, it means that angle K is equal to angle L, which is equal to alpha. The other thing that you need to know about isosceles triangle is that when you drop the perpendicular from MN, then angle beta is cut in half, and the side KL is cut in half. So because this is an isosceles triangle, and because MN is a perpendicular, we can say that KN is equal to NL, and that is half of 30. So this is actually 15, and this is 15. Now I know we have not done enough geometry for you to know this, but I just wanted to try this sum and let you have an opportunity to see how it works. So because this is an isosceles triangle, we can say that KL is equal to KN is equal to NL, which is equal to 15, and that is because we dropped the perpendicular. So now I've got two triangles. I have KNM and I have LNM. They are identical triangles. They are actually congruent. Now, I want to work out angle A. For me to work out, not A, alpha. For me to work out angle alpha, I need two sides and an angle. I have this side, which is 15, and this 15 side is actually adjacent. And I have this side, which is 20, and that is my hypotenuse. Based on SOHCAHTOA, if I have adjacent and hypotenuse, I actually have cos. So I can say cos of alpha is equal to adjacent 15 over hypotenuse 20. I want the angle alone. In order to get the angle, I'm going to use the inverse function. So I'm going to say alpha is equal to cos minus 1 of 15 over 20. And I put that in brackets, especially on the calculator. Now that I have that, I can actually input it into the calculator, and I can say shift cos 15 over 20 close bracket is equal to 41,4096. 41,4096. Alpha is equal to 41,4096 dot dot dot. Now they want us to do it to 2 decimal places, so alpha is equal to 41,41 degrees, and that is the answer for alpha. The next thing that we need to calculate is the angle for beta. So how would you like to do this? You can use trigonometry, where you're going to say we have got two sides, hypotenuse and opposite. So you can say hypotenuse and opposite. That gives us half of beta, and then you multiply the answer by 2. Or you can use the sum of the angles in a triangle. So what do we have here? We have got 90 degrees. We've got alpha, which we've just figured out. So I know that half of beta plus alpha plus 90 degrees equals 180 degrees. Because we are doing trigonometry, I'm going to use the trigonometric way of doing it right now. You, on the other hand, can use whatever way, unless the question specifies use trigonometry only. So here goes. If I'm going to say, let's use this angle. So we're going to say half of beta is going to be opposite and hypotenuse, right? Opposite and hypotenuse is sine. So I'm going to say sine of half of beta, beta over 2, is equal to, sine of beta over 2 is equal to opposite 15 over hypotenuse 20. So I said beta over 2, which is the same as saying half times beta. That's exactly the same thing. So now what do? I want to have beta alone, right? Notice that this here is one entity. So when I'm going to say sine minus 1, I am going to say sine minus 1 of 15 over 20, because I'm using the inverse function, and that is going to be equal to half of beta. Now you input that into your calculator. I'm going to say shift sine 15 over 20, close bracket, is equal to 48,59. Okay, so half of beta is equal to 48,59 ... But I don't want half of beta, I want full of beta. So I multiply this side by 2 so that that cancels out, and I have a full beta. And I multiply this side by 2, so my answer is going to be beta is equal to, I still have my answer, so instead of typing anything, I'm just going to say that multiplied by 2, which gives me 97,18 if I round it off to 2 decimal places. 97,18 ends up being my size for beta. And remember, beta is the full angle M from this side to that side. Okay, I hope that made sense to you. This is the end of this video. Please like and subscribe. Please continue to work hard. I am very, very proud of you. I will see you in the next video. Any questions, please text me, or I'll see you in class. Bye-bye.